All right, so we started talking about naming branch-chained alkanes. What that means is we've got not just a nice single row of carbons, but we've got these branches that come off the sides of them, all right? And so we want to deal with how to name those particular ones at this point. And then we'll continue on and talk about double bonds and triple bonds, all right? We started a couple of examples, and so at this point, talking about the rules makes a little more sense after we've done one or two of them than just when we started, because it didn't have any sense. But identify the parent chain. And we did that for the first one. We'll do that again in a moment. But we always need to find that longest chain. The longest chain is going to define the main name, the parent name, all right? If it's cyclic, all right, the number of carbons in the ring is the parent name or the base name. So the ring defines that longest chain, all right? We don't actually find a long chain that maybe has a piece of the ring and then goes out the other side. The ring becomes the main part, all right? The number of carbons along the parent chain beginning at the end, which results in the lowest number of branches. So we give the main parent chain an address, a series of numbers, just counting them off. And we always start with the end that's going to give us our lowest numbers. And you can determine that visually by kind of looking at which end the branches are kind of clumping at. You can kind of see they're either at one end or the other end, okay? Name each branch. And when we say name each branch, we're talking about things like methyl groups, which is a CH3 missing one H that can then bond onto the chain, or an ethyl group, which has C2H, what would it be? Normally it's C2H6, right, because it's the 2N plus 2. But C2H5 would be the methyl group, ethyl group, et cetera, and we'll go over some of these. Write the branches in alphabetical order. If the same branch appears more than once in the chain, the quantity of identical branches is indicated by a prefix, di, tri, tetra, penta, etc. These prefixes do not affect the alphabetical order. Put everything together, number, and then a dash, then the branch name, then a dash, then the number, then the dash, then the branch name, depending on how many branches you have. We always separate numbers from words with a dash. Okay, so let's zoom in here so that we can see a little better here. And let's name some of these guys that we were dealing with here. So I'm going to move here off to the side. And I think we've already done this one, but we'll do it again. So looking at this particular chain, right, I see here 1, 2, 3, 4, 5, 6. So that's a 6 chain right there. I maybe think 1, 2, 3, 4, 5, but no, that's not the longest one. So 1, 2, 3, 4, 5, 6. So this is obviously a hexane, and I like to write that down already, hexane. That's my end part of the name. We start by numbering at the closest end, 1, 2, 3, 1, 2, 3, 4. So this is 1, 2, 3, 4, 5, 6. And here's our group right there. This is a methyl group, all right? It's at the number 3 position. So this becomes 3-methyl. And look at, I put a space in there, but that should actually go together as one. But you know what, if you leave a little bit of space in there because you put the base name first and then put the 3-methyl, that's good enough, all right? So that's 3-methyl hexane, okay? We encountered this one already, and I'm going to go quickly. I think we've got the answer to these, so I'm just going to go quickly through it. So we've got 1, 2, 3. It doesn't matter which way we make the chain. It is identical. I have 2 methyl groups, and you might think that I should put a number 2 to describe the position. But if this methyl group was on this end carbon, it would turn my propane into a butane. And so in this case, there's no need for numbers because you can't put a methyl on an end carbon. As soon as you put a methyl on an end carbon, you've extended the chain really by 1. So having a methyl on an end carbon is not an option. So we call this simply dimethyl, and I'm dropped an H, dimethyl propane. And in this case, there's no need to say 2-dimethyl propane, because if I had a 1 or a 3, it would be a butane. It wouldn't be a propane anymore. So no numbers needed for this. If I said to you on a little quiz, which probably will happen on Friday, draw dimethylpropane, you would draw your propane, and then as soon as you thought about putting your methyls, you'd say, oh, I can't put it on the end, so I got to put them in the middle. And you would come up with the proper structure with just saying dimethylpropane, no need to say the two. So if the number isn't needed, we don't put it, okay? It's only if the number is needed because of an ambiguous situation. If I just said here methylhexane, you would know not to put it on the first one and the last one, but you'd have 2, 3, 4, well, actually you'd only have 2 and 3 because 4 and 5 would be the same on the flip side, but you'd have 2 or 3, and your question would be, which carbon do I put it on? So we need the number in that case. All right, let's take a look at this last one over here. Okay, let's do these. So, what's the longest chain in this one? You guys tell me. Longest chain. Yep. 1, 2, 3, 4, 5, 6, 7, or 1, 2. Oh, you're doing this hard one over here? Let's do this one here. 1, 2, 3, 4, 5, 6, 7. Heptane. Excellent. 1, 2, 3, 4, 5, 6. Just checking, right? So it's a heptane. I agree. So it's a heptane. And 1, 2, 3, 4. 1, 2, 3, 4. It's in the middle, right? So it's in the number 4 position. Sorry? Yeah, we're calling this an ethyl. Excellent. Ethyl. So this is 4-ethylheptane. I could put that ethyl on the number 2 position, right? Or sorry, the number 3 position, okay? And that would be a valid thing, so I need the number. If I put the ethyl in the number 2 position, then it would become the longest chain. So just like I would never put a methyl on the end one, I would never put an ethyl on the second last one, because it would make the longest chain. Now, as soon as I introduce double and triple bonds, that changes things. That's only if it's all single bonds. As soon as I introduce double and triple bonds, then the naming rule changes that could be a case. So we got to watch it. Yes? No, in this case, I was counting both ways to see which would give me the smallest number, but because it's right in the middle, it doesn't matter which way I count from. It's always got to result in the smallest numbers for the branches. That's how you determine which way. Right, so let's take a look at this one here. So somebody told me a nonane, what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just check here for a second. 1, 2, 3, 4, 5, 6, 7, 8, 9. Either way, it doesn't matter. So we'll go across this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're right, it's a nonane. Nonane, I think Joe was telling us it's a nonane. In terms of groups, I've got a methyl group, and this group here is a ethyl group. And now we've got to pick sides for numbering. You'll notice it's identical. 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. So you might think it doesn't matter. But when you have choice, what are we going to choose? Why would we pick methyl first? Oh, nice try. You could think because it's the smaller one, you're going to pick it first, but that's not what we go to. Whenever you've got a question mark, you default to this. What do you think, Joe? Alphabetical. Whenever you've got a question mark, default to alphabetical. So ethyl, because it's alphabetically first, will get the smallest number. 1, 2, 3, 4, 5, 6, 7. We start with the ethyl first, because it's alphabetically first. 3, ethyl, another dash, 7, dash. Separate numbers from words with the dash. 7, methyl nonane. The words all roll together, no space. Back down to here. Okay, let's take a look at this one. Longest chain, has anybody found it? 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. I didn't do anything exciting, like go down around the corner. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's looking like 9. So again, base name, nonane. Nonane. Now my groups. Goodness gracious. Look at all these groups here, or these branches. What are they all branch examples of? They're methyl. They're methyl groups. Now I need the smallest numbers. 1, 2, 3, 1, 2, 3. Those are identical. But this guy's closer to the left side. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8. We don't, I guess, don't need the 7, 8, and 9, but we get the idea. So now I'm going to have 1, 2, 3, 4, 5 methyls. I need a prefix that indicates 5. So I have to have pentamethyl. 5 methyls. If it was 2, it's di. If it was 3, it's tri. If it's 4, it's tetra. And then if it's 5, it goes back to what we have as 5 carbons as well. So it's pentamethyl. So this is a pentamethyl. Pentamethyl. And now each branch gets its own number. So I need 5 numbers. And so it looks like this. I have 2 at 3. So it becomes a 3, 3. You separate numbers by commas, and you separate words by dashes. So it's 3, 3, 4, 7, 7, dash. So everyone gets their own number. 3, 3, 4, 7, 7, pentamethyl nonane. Nonane. All right? What a great name. Okay. Now we've got a cyclic one. We don't include the external branches as the main name, just the chain. 1, 2, 3, 4, 5. That makes this a, cyclopentane. Very nice. I got a branch. If I had 2 branches, I would need numbers. But there's only 1 branch. So if I say methylcyclopentane, you'll just stick a methyl off of one of them, and you'll always get the correct answer. No number needed here. So this is just methyl, no space in there, but I'm okay if you do it backwards the way I do. I always do it in reverse. Do the base name first, then put the stuff on the front. Methylcyclopentane. All right. Okay. 1, 2, 3, 4, 5, 6. A cyclohexane, right? Cyclohexane. Now notice this is not benzene. Benzene has these alternating double bonds. That's a different thing. It may have a ring like 6, but it looks different. Groups. I got a methyl and an ethyl. You don't have to write it down every time. I'm just writing it down to, you know what I mean, to show you what we're doing. So now I do need numbers because they could be at 1 and 2 or 1 and 3 or 1 and 4, okay? One of the branches always gets number 1. Again, we're to the point where it's like, which one gets number 1? And whenever you have that question mark, what do we default to? Alphabetical. So who gets the 1? Yeah, 1 ethyl, 1 ethyl, and what are we at then? 1, 2, 3. Clockwise, counterclockwise, meaningless. Because you can flip these things around. It's whatever gives the smallest numbers. 3 methyl cyclohexane. Okay? So that deals with examples of multiple branches and different branches and how they're numbered and cyclo versions of that have cyclic ones. Okay. So now we're just to, let's draw some structures. And I'll move this over here so we got lots of room. Drawing structures is easy, folks. I've already kind of given you a little heads up about when you did the isomers. Draw just the carbons and leave a little space behind it so you can insert your H's at the end depending on how many branches they have. So when I look at something like hexane, I am going to draw C, and I'm better at it on the board, but you get the idea. What have I done? 4, 5, 6. Okay? Now I'm going to put on my branches a 3 ethyl. So 1, 2, 3. And when I'm drawing, I always go from left to right, right? So 3 ethyl, and you don't have to draw them as separate. I'm going to show you some examples later on that looks like this. Ethyl is going to be C2H5. Just draw it like that. That's good enough. I don't need them separated out. If you did that, that's fine. It's not wrong. But to me, that's valid. That's good enough. That's an ethyl group. When you draw it like this, sometimes we think C2H6, because that's the 2N plus 2. But to give it a bond to stick to the branch, we have to take one of the H's away. So it's C2H5. The methyl group is in the number 2 position, and you can put them all up. It doesn't matter. CH3. You could put one up, one down. They rotate. It doesn't have any effect. Now that I've got all my branches on, I can finish my H's. There's one bond there. That's an H3. There's 3 bonds there. That's an H. That's an H. That's an H2. That's an H2. And that's an H3. When we do our quizzes, because I'm going to give you a couple of quizzes throughout this run just to make sure that we're kind of keeping up with the naming, don't forget your H's. Sometimes we get in a hurry. We draw all those C's. We think we're done. Don't forget to go back and do the H's. Butane, 1, 2, 3, 4. 2,2,3 trimethyl. CH3, CH3, CH3. Now the H's. H3, none, H, H3. Drawing is easy. Drawing's kind of fun, right? All you're doing is building it. You don't have to think quite as much. So we got a cyclopentane. Now, I'm going to introduce you to a little shortcut. And you've already seen it when I showed you that little program. I have no problems drawing cyclic structures as just the shape. So if this is cyclopentane, I will allow you to just draw the pentagon and assume that it's got 2 H's hanging off the side. We don't need to see them. So this is a little introduction into the shortcut version, but I do still want you to draw the chains out like this, because I don't want you to get, it can be tricky when we get very complicated. But for the ring, if you want to do a shortcut, that's great. But if you have here a bunch of CH2s, CH2s, that's fine as well. 1 ethyl, so we'll put that as 1. C2H5 is our ethyl. And 3 methyl. So 1, 2, 3, CH3. And I go counterclockwise again when I'm drawing just because that's easiest. So 1 ethyl, 3 methyl cyclopentane. Excellent. That gets you full marks right there. Okay? Okay. And what do we got? A heptane and a diethyl. All right. So 1, 2, 3, 4, 5, 6, 7. And I got a 1, 2, 3. So I got a 3-ethyl, C2H5. And I've got a 4-ethyl. And just because I'm out of room up top there, C2H5. And an H3, an H2, an H, an H, an H2, and I'm getting squishy in here. You guys are better. You guys will be better. Whoops, that's an H3 on the end. Boom. Okay?